Hi all, welcome to Sidza.com. Now let's learn about the rate constant K and what are its characteristic features. In our last video, we have discussed what the rate constant K is. Let's have a quick recap of that. According to the rate law, rate of any reaction depends on the concentration of the reactants, right? And if suppose you got here the reaction is A plus B and it produces the C, according to the rate law, the rate of a reaction will be equal to rate constant K times concentration of A power alpha and concentration of B power beta, right? And alpha plus beta, this is called as an order of a reaction. We have discussed about it, what it is. So this is an order of a reaction, and when you take the concentration of A 1 unit, right, suppose 1 mole per liter, and the concentration of B is also 1 mole per liter, so this whole term becomes 1, and the rate of a reaction will be equal to rate constant K. So you can say the rate constant K is the rate of a reaction when the concentration of each reactant is taken as unity, right? Now let's discuss its different features, different characteristic features. Rate constant K, it is the measure of the rate of the reaction. That means K value for any particular reaction tells us whether the reaction is slow or the fast. Okay, so higher K value means the reaction is faster, right? If the rate constant K has a higher value, so which means that the reaction is faster, right? And lower K value means that the reaction is slow. Each reaction has a definite value for the rate constant K at a particular temperature. That means if you have a reaction, suppose you got this one, nitrogen and the hydrogen, and it forms the ammonia here, and this is the balanced chemical equation. The rate constant K for this particular reaction, since it's a constant, it doesn't mean that the K will have the same value under all the conditions, right? It's a constant, but doesn't mean that the rate constant K for this particular reaction will have the same value under all the conditions. The rate constant K depends on the temperature, right? It means if you change the temperature for the same reaction, the rate constant K will be different. So at suppose here 300 kelvins and 400 kelvins, the reaction, the same reaction will have different K values. So it depends on the temperature. Rate constant K for a reaction changes with temperature, the same thing, right? If you keep the temperature same, it's constant. If you change the temperature, it will also change. Now catalyst also increases the rate of a reaction. Why? Because we know that a catalyst can increase the rate of a reaction. When you add a catalyst, the reaction becomes faster. So therefore the rate constant K will also change. So catalyst can alter the rate of rate constant K. This rate constant K is independent of the initial concentration of the reactants, right? Because by definition we know that rate constant K is the rate of a reaction when the concentration of each reactant is taken as unity. So it doesn't depend on the concentration of reactants. The last but the very important point, what are the units of this rate constant K? The units of the rate constant K, it depend on the order of a reaction. So it will change, right, with the order of a reaction. So the K has different units, depends on the order of a reaction. Suppose we got here a reaction, right, in which the reactants change into product, and suppose this is the order of here is N is the order of a reaction. So I can say here that the rate of a reaction will be equal to K. It depends on the concentration of the reactants power N, or you can say the rate of a reaction will be equal to K times concentration of reactants power N, right? And the rate, we normally write down the change in concentration. Rate of a reaction means the change in concentration, right? So I'm going to write down the change in concentration, right? Let's say delta X here by delta T. Change in concentration by delta T, change in time will be equal to K. And what is this one? This is concentration, right? Power n. Okay, so this has got the units of concentration, change in concentration. Del X is the change in concentration, so it has the units of concentration, and delta T is the time, right? It has a unit of time. So it will be K times concentration, right? Power n, right? Because this is the concentration of the reactants, power n. Or you can say here the rate constant K will be equal to concentration upon time. Time is 1 by concentration, power minus, power n, right? Or I can write down the same equation here. I can say the rate constant K will be equal to concentration power 1 minus n by time, right? So this is the equation, and from here I can find the units of the rate constant K, right? You can find the units of the rate constant K here. So let's suppose we got the zero order reaction. That means the zero order reaction means the n is 0. So then, therefore, what will be the units of the K there? For a zero order reaction, right? For n equal to 0, K will be equal to concentration power 1 minus n, right? Concentration power 1 minus n, 1 minus 0. So basically it will be the concentration, which is 1 minus 0 is 1, so divided by time. And we know the units of the concentration. What are the units? It's moles per liter, right? Moles per liter, time inverse, right? And time has the units of, you can say, seconds. So units will be now, it will be, the K will be moles per liter per second, right? So this is for the zero order reaction. The K has moles per liter per second. Now what about first order reaction? If n is 1, K will be, it has a concentration power 1 minus 1, that is 0, right? So by time. So now it will be only time inverse, right? So you can say per second for the first order reaction, right? For the first order reaction, the units of the K will be time inverse. Now what about the second order reaction? If n is 2, then the K will be concentration upon time. Here 1 minus 2 is minus 1, right? It will be minus 1. So it has moles per liter, right? Concentration is moles per liter, and the power is minus 1. Here is the time. So you can see it is liter per mole per second, right? Liter per mole per second, right? This will be the units for the second order reaction. Hope you got the concept. Thanks for watching the video. Bye for now.